This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at inverse functions, part 2. First part was algebra based. These are trig based. And I guess I should have had my tablet up and running, so let me get that going. And there it goes. Okay, our first problem. We got arc cosine of negative 1/2. Let's try it again. Okay, now we don't know what this is equal to, so we're going to say equal to a variable. So set it equal to p, for example. Now we can take cosine of both sides, and we've got cosine of arc cosine of negative 1/2. And so we end up with cosine p is equal to negative 1/2. Because cosine and arc cosine cancel each other out. Well, remember for arc cosine, that's valid in our first two quadrants here. Now specifically, this one says that cosine is equal to a negative number. Well, cosine, which is our x on our unit circle, is equal to a negative number here and here. So the quadrant we're looking at is quadrant 2. So let's look in quadrant 2 and see where cosine is the x part on our unit circle, cosine is equal to negative 1/2. Okay, so we're over here in quadrant 2. We're looking at cosine, our x part. It's equal to negative 1/2 right here. So there'd be 2 pi over 3. So this is equal to 2 pi over 3. And that's our answer. This next one, we have arc sine of negative 1/2. And again, we don't know what this value is, so you can just set it equal to a variable. Set it equal to p. And we need to find out what p is, and that's our answer. Well, we can take sine of both sides. So sine p is equal to sine of arc sine, negative 1/2. Well, sine and arc sine cancel each other out, so you got sine is equal to negative 1/2. Okay, let's think about our quadrants. Arc sine is valid in these two quadrants, from negative pi over 2 to pi over 2. And sine is specifically negative. Sine is our y. It's specifically negative in this quadrant and this quadrant. So the quadrant we're dealing with is quadrant 4. Okay, so we're going to go look on our unit circle, and we're trying to find out where sine, which is our y, is equal to negative 1/2. Well, we're in quadrant 4. Sine is our y part of our point, which is right here, and it's equal to negative 1/2, so it's 11 pi over 6. Now there's a problem with this one. Arc sine is specifically valid from negative pi over 2 to pi over 2. It doesn't exist at 11 pi over 6. So what we need to do is we need to subtract 2 pi. Now this is a mixed number. We take negative 2 times 6 is negative 12 plus 11, and we end up with negative pi over 6. And that's our answer. Oops. Okay, number 3. We've got arc tangent of negative square root of 3 over 3. Again, set it equal to a variable, so set it equal to p. And we'll go ahead and take tangent on both sides. So we got tangent p is equal to tangent of the arc tangent of negative square root of 3 over 3. So tangent and arctangent cancel each other away. So you got negative square root of 3 over 3. Okay, well, let's think about our quadrants. Arctangent is valid in the first and fourth quadrant. Tangent is equal to a negative. Well, tangent is equal to a negative when the signs are different, because tangent is y over x, and so one of them had to be different, or one of that be positive, one had to be negative. They have to be different signs. They're different signs in quadrant 2 and quadrant 4. So where they're both valid is quadrant 4. Okay. Now, if we look in quadrant 4, we're going to have 11 pi over 6, and this is square root of 3 over 2 and negative 1/2. And the other one we have, I have to think this through now, pi over 3, 2 pi, 4 pi, 5 pi over 3. And this one is 1/2 and negative square root of 3 over 2. Now tangent is y over x. So if I look at this one, y over x, this is going to be negative square root of 3 over 2 over 1/2. 2's would cancel, and you'd end up with negative square root of 3. So that one doesn't fit. But this one, y over x, I'm going to have negative 1/2 over square root of 3 over 2. 2 is going to cancel, and we've got negative 1 over square root of 3, and multiply top and bottom by the square root of 3. And you'd end up with negative square root of 3 over 3, which is what we're looking for. So it's 11 pi over 6. But we got a problem. Is this the same as the one up here? Yeah, it is, isn't it? Arctangent is only valid from negative pi over 2 to pi over 2. This is not in that range. So what we need to do is we need to subtract 2 pi. So if we subtract 2 pi, we're going to end up with negative pi over 6 again, which is our answer. Sine is our y is equal to negative 1/2. Well, sure enough, it is the same angle. Let's take a look at the next problem. Got our cotangent of the square root of 3. Okay. And now we need to set it equal to a variable again. I'm going to glance to make sure I have down what our cotangent is, where it's valid at. I think it's 0 to pi. But let me double check this. I think that's that weird one. Most of them you can kind of look at them, they make sense. But the arc cotangent, let's see, yep, 0 to pi. Okay, so again, we'll set equal to a variable, set equal to p. Sometimes my memory's not that great, so. And then I'll take cotangent on both sides. So we got cotangent p is equal to cotangent of arc cotangent, square root of 3. Well, cotangent and arc cotangent cancel each other out. So we got cotangent p is equal to square root of 3. Okay, now let's think quadrants. I said already the arc cotangent is 0 to pi. Now, arctangent is valid from negative pi over 2 to pi over 2, these two quadrants. So you'd expect arc cotangent to be here. So that's why I say it's not like what you might think. Now, so this says cotangent is equal to square root of 3. Arc cotangent is x over y, so it's equal to a positive number. Well, the only way you can get a positive number is when the signs are the same. If you have a positive over positive, that gives you positive. If you have a negative over a negative, they give you a positive. Well, where the signs are same are first quadrant here and the third quadrant, sorry. So the quadrant we're dealing with is the first quadrant. Okay. So here in the first quadrant, we have pi over 6, and we have pi over 3. Now this point here is the square root of 3 over 2 and 1/2. And this one is 1/2 and square root of 3 over 2. Now cotangent is x over y, so if I put this x over this y, we'd have 1/2 over square root of 3 over 2. The 2's would cancel. You'd have 1 over square root of 3, which is square root of 3 over 3. Not what we're looking for. Now this one, if I put x over y, I'm going to have square root of 3 over 2 over 1/2. 2's would cancel, and they have square root of 3 over 1, or square root of 3, which is what we're looking for. So that would give us pi over 6. And our cotangent is valid from 0 to pi, so that we don't have to do any kind of subtracting or any kind of weird thing like that. Let me save that page. And we'll get there eventually. There we go. Part 2. Page 1. And let's look at our next problem. So we got cosine of arc sine negative 1/2. I'm going to do these ones a little bit different than the instructions kind of imply. They say sketch a right triangle, but we'll do it another way. One thing to remember, and this is where you got x, y, and r formulas. Cosine of our angle is equal to x over r. Sine of our angle is equal to y over r. Tangent of our angle is y over x. Secant of our angle is r over x. Cosecant is equal to r over y. And cotangent is equal to x over y. Now, first thing we do on these problems is we're going to take a look at what's inside the parentheses and set it equal to a variable. So we'll set arc sine equal to p. So we've got p is equal to arc sine of negative 1/2. Just like the previous problems, we're going to find out what p is. So we'll go ahead and take sine of both sides. So we got sine p is equal to sine of arc sine of negative 1/2. Sine and arc sine cancel each other out, and you're left with negative 1/2. Now let's think quadrants. Arc sine, that's valid from negative pi over 2 to pi over 2, so these two quadrants. Now this is saying sine is equal to negative 1/2. Sine is y, so that's our y. So that's saying y is negative, which is in third quadrant and fourth quadrant. So where they're both true is quadrant 4. Okay, now remember, sine is y over r. R always has to be positive, so even if I didn't know what quadrant this was in, we can't have the negative down on 2. So y is equal to negative 1 and r is equal to 2. Now in order to use these formulas over here, we need x, y, and r. Well, we got two of them. We just need to find x. So we got x squared plus y squared is equal to r squared. X squared plus negative 1 squared is equal to 2 squared. Negative 1 squared is 1. 2 squared is 4. Take the 1 over and we get x squared is equal to 3. Drop our squared and put a plus or minus square root around the other side. Square root property from college algebra. Now down in this quadrant here, in quadrant 4, x is positive. So we're going to have x is equal to the square root of 3. Okay. So we're done working with what's inside the parentheses. Now we're going to go to our what's on the outside. So we're going to take a look at cosine. Cosine is x over r. So our answer, we just found x was square root of 3, and r was 2. So our answer was square root of 3 over 2. Now this one actually fell on our unit circle, so we didn't have to actually do all these steps. It would have been a lot easier just to look at the unit circle. But I want to show these steps because these are the same ones we can use to solve any of these problems. And they help refresh your memory on the x, y, and r formulas from Trig. Okay, let's look at our next one. We got tangent of arc cosine of 3/7. Obviously 3/7 isn't on our unit circle, so this is one where you couldn't go to the unit circle. You have to do it with these steps. Now first thing, we work with what's inside the parentheses, so we'll set it equal to p. So we got p is equal to arc cosine of 3/7. I'm going to go ahead and take cosine of both sides. So we got cosine p is equal to cosine of arc cosine of 3/7. Now cosine and arc cosine cancel each other out, and we got cosine is equal to 3/7. Okay, well let's think about our quadrants. Arc cosine, that's valid from 0 to pi, these two quadrants. Here, cosine is equal to a positive number. Cosine is our x, so where x is positive is quadrant 1 and quadrant 4. So the quadrant we're dealing with is quadrant 1. Now remember, cosine is x over r. Well, the number on top is 3, so x is 3, and r is 7, number on the bottom. To use those formulas, we need x, y, and r, so we just need to find y. So we've got x squared plus y squared is equal to r squared. X is 3, so we've got 3 squared plus y squared equals 7 squared. 9 plus y squared is equal to 49. We've got y squared is equal to 49 minus 9. Y squared is equal to 40. Drop the squared, put a plus or minus square root around the other side. Now we're talking about quadrant 1, and in quadrant 1, y is positive, so we'll drop the negative. So y is equal, and this simplifies. 40 is 2, 4, 8 times 5. We're looking for a pair of numbers. Here's a pair of 2's. So we're going to have y is equal to 2 square root of 10. Assuming I didn't screw up my basic math. Now let's look at the outer trig function, tangent. Tangent is y over x. So we just said y was 2 square root of 10. And x was 3. So that's our answer. Let me save that page. Excuse me. And let's look at our next problem. Okay, so we got secant of arctangent of negative 4/3. Okay, so again, we're going to start with what's inside the parentheses. So we'll set that equal to p. So we got p is equal to arctangent of negative 4/3. Now we'll go ahead and take tangent on both sides. So we got tangent p is equal to tangent arctangent of negative 4/3. Now tangent and arctangent cancel each other out, so that's going to leave us negative 4/3. And let's think our quadrants through. Arctangent is valid from negative pi over 2 to pi over 2. Now this is saying tangent is equal to a negative number. Well, tangent's y over x, and the only time you can have that equal to a negative number is when the signs are different. One's positive, one's negative. Well, signs are different in quadrant 2 and quadrant 4. So the quadrant we're dealing with is quadrant 4. Now in quadrant 4, x is positive and y is negative. So remember, tangent is y over x. So y is equal to negative 4 and x is equal to positive 3. Now this negative was on top, but if we had a different quadrant where y should be positive and x negative, you want to put this negative down below. So you have to adjust that accordingly. Well, we need three things. We need x, y, and r, so we need to find r. And we can use this formula. R is equal to square root of x squared plus y squared. So we got, let's see, 3 squared plus negative 4 squared. And this looks like a nice 3, 4, 5 relationship. So we got 3 squared is 9 plus negative 4 squared, which is 16. So we got r is equal to square root of 25. So r is equal to 5. Well, now let's take a look at our outer trig function, the secant. Secant is r over x. So r we said was 5, and x we said was 3. So our answer is 5/3. Okay. Next problem. Great. We got y is equal to arc cosine of x minus 1. And we want to find out cosine y. Well, this one we don't really need to use a triangle, but let's just talk about this triangle. If I start out with this right here, and these next problems are based around these formulas here. Cosine of our angle, and they use y here, but so cosine of our angle is equal to adjacent over hypotenuse. Sine of our angle is equal to opposite over hypotenuse. Tangent of our angle is equal to opposite over adjacent. Scratch my eye here. There it goes. Okay. Secant is cosine flipped, the reciprocal of it. So this will be hypotenuse over adjacent. Cosecant is the reciprocal of sine, so this flipped. So this will be hypotenuse over opposite. And cotangent is tangent flipped, reciprocal of it. So we're going to have adjacent over opposite. And what we're talking about there with that is if we got angle, wherever you put it, let's put it right here. We got an angle here. The side opposite of it is your opposite side. It's kind of obvious. And this is your adjacent side, adjacent to that angle. And the side that's opposite your 90 degrees is always your hypotenuse. And we got the Pythagorean Theorem. It says the hypotenuse squared is equal to opposite squared plus adjacent squared. Okay, so let's take a look at this. Now they're telling us that the angle y is between 0 and pi over 2. So what they're indicating to us is everything's positive, so you don't need to worry about signs. Okay, so we're going to go ahead and take cosine of both sides. Excuse me. And cosine and arc cosine cancel each other out, and we got x minus 1. Now, we need cosine to be in a fraction form. You can always create a fraction by putting it over 1. So I'll put that over 1. Now, let's take a look at our triangle. Here's our angle, y, and that's just what they choose here. Cosine is equal to adjacent over hypotenuse. Well, this is the adjacent, so this would be x minus 1. And hypotenuse would be this side, so this would be 1. That's the picture they give us. That's how they get that. Well, this is our opposite side to this angle. So we're going to use a Pythagorean theorem to get that. So if we look at hypotenuse squared is equal to opposite squared plus, let me erase that, there we go, plus adjacent squared. Well, hypotenuse was 1, so we got 1 squared is equal to opposite squared, which we don't know, plus adjacent, which is x minus 1 squared. Well, this is 1, and if I take the x minus 1 squared over the left side, it becomes a minus x minus 1 squared equals opposite squared. Now we'll drop our squared, and normally you'd put a plus or minus on the other side, but we can't have a distance being negative. And specifically, they tell us everything's positive. It's in quadrant 1. So we're just going to have a square root of 1 minus x minus 1 squared. Now that's our opposite side. Okay, so that's your setup. This will be square root of 1 minus x minus 1 squared. Well, what they're wanting us to find here, and this one's real easy, cosine y. Reason why I say it's real easy is we just found it right up here. We know what cosine y is. Once we took cosine of both sides of this, we got that. So our answer on this one is x minus 1. Now the other ones won't be as simple as this. Go ahead and save that. I mean, they're not difficult or anything, but this one is pretty obvious. I don't know why it flips me out of that every time I save it. And I'm not sure why it blows up, but let's get a new tablet going. There we go. And let's look at our next one. Number 9. Now, using the same thought process as before, I'm not going to go through all the steps. This was x minus 1, this is y, this is 1, and this was a square root of 1 minus x minus 1 squared. Okay. Now, what we're trying to find here is tangent. Now, tangent is equal to opposite over adjacent. Well, this side is opposite, so this is going to be square root of 1 minus x minus 1 squared over adjacent, which was x minus 1. Now, the hard part was getting this side initially, the opposite side. So once we have that, then these are pretty simple now that I say that. Okay, cosecant. Well, sine was opposite over hypotenuse, so this will be hypotenuse over opposite. Well, the hypotenuse was 1. Opposite was this square root, so we'll have square root of 1 minus x minus 1 squared. And I'm going to leave it in that form. You'll find where in intermediate algebra, algebra 2, they told you to get rid of any square roots down below. When you get to calculus, a lot of times you'll leave it there because it's actually easier to work with in that form to try to put a square root up here. So, okay, let's take a look at number 11. We got secant, arc cosine of 3x. And it says write the expression in algebraic form, hint, sketch a right triangle. And so let's start with what's inside the parentheses here. So we'll set that equal to a variable, set equal to p. Like that. And then we'll take cosine of both sides. So we've got cosine p is equal to cosine of arc cosine 3x. And cosine and arc cosine cancel each other out. So you got 3x, and I'll put it over 1 to put it in fraction form. Now remember, cosine is adjacent over hypotenuse. So if we do our triangle here, if this is P, because I chose P, adjacent. Adjacent would be 3x, so this would be 3x. Hypotenuse would be the number down 1, because it's down denominator. And this would be our opposite side, so we need to use Pythagorean Theorem to get that. Well, we got opposite squared plus adjacent squared is equal to hypotenuse squared. So we got opposite squared plus adjacent is 3x. So we got 3x squared is equal to hypotenuse squared. So we got 1 squared. So opposite squared plus 3x squared gives us 9x squared equals 1. Take 9x squared to the right side, and we got 1 minus 9x squared. Drop our squared and put a square root around the other side. So we got 1 minus square root of 1 minus 9x squared. Okay, so we got our opposite side. Now let's look at the outer trig function secant. Now cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And as weird as it seems, we didn't actually need opposite on this, but typically your guideline is you find your opposite, adjacent, hypotenuse, and use your formulas. I'm going to talk about a shorter way to even work this one in a second. Okay, so let me see. Hypotenuse, where was that at? I didn't write it down. Hypotenuse is 1 over adjacent, which is, let's see, 3x. So that'd be your answer. Okay, a shorter way to do that one. I wanted to show that because that shows all the steps. But easier way, we got secant of arc cosine of 3x. Now recall, secant is equal to 1 over cosine. So I could rewrite this as 1 over cosine of arc cosine of 3x. And cosine and arc cosine cancel each other away, so we're left with 1 over 3x, which is what we came up with there. Now that's just using basic identities, but I didn't want to use identities. I wanted to go through this process to show it to you. Let me save that page. And let's look at our last problem. This one's a little bit more interesting than that previous one. So we got cosecant of arc tangent of x minus 1 over 2. Okay, again, we're going to start with what's inside the parentheses, set equal to p. So we got p is equal to arc tangent of x minus 1 over 2. We'll take tangent on both sides. So we got tangent p is equal to tangent of arc tangent x minus 1 over 2. Now tangent and arctangent cancel each other away, so we got x minus 1 over 2. Tangent is opposite over adjacent. So let me actually write it down this time. Opposite is equal to x minus 1, and adjacent is equal to 2. So let's come up here and draw a triangle. Here's P. Opposite would be x minus 1. Adjacent is 2. What we're missing is the hypotenuse. So we got hypotenuse squared is equal to opposite squared plus adjacent squared. Opposite is x minus 1, so we got x minus 1 squared plus adjacent, which is 2, so plus 2 squared. Now we'll drop the squared, and we'll put a square root around the other side. And we got x minus 1 squared plus 4. Now let's look at our outer trig function. Cosecant is our hypotenuse. Always have to think of sine first. Sine is equal to opposite over hypotenuse, so this is hypotenuse over opposite, because they're reciprocals of each other. Well, our hypotenuse was square root of x minus 1 squared plus 4 over my opposite, which was x minus 1. And that's our answer. And I believe that was the last problem, so let me save this. stop the recorders.